Good evening, guys. So today we'll be taking up a problem on kinematics, and we'll be taking up a problem which is based on the topic of relative velocity, right? And relative velocity is a kind of an important topic, something which might be, sometimes problematic to some students. So we'll be taking up a question which has been asked in a JE before on the topic of relative velocity, right? So without further ado, let's go on to the question. So let me share the screen with you guys. So there's a question over here. We have two airplanes A and B, and they are flying with constant velocity. So the direction is same and the speed is same. And they fly at angles of 30 degrees and 60 degrees with respect to horizontal. So these are your two aircrafts. One is flying at an angle of 30 degrees. The other one is flying at an angle of 60 degrees. And the speed of A is given as 100 √3 meters per second. And at some time t is equal to 0, an observer in A finds the aircraft B to be at a distance of 500 meters. Right, and this observer sees B to be moving with a velocity perpendicular to the line of motion of A. So from A's frame of reference, that is from a person inside this plane, he observes plane B to be moving in a direction perpendicular to the line of motion of A. Right. So if at t is equal to t naught, A just escapes being hit by B, then what is the time t naught is equal? What's the time t naught is equal? Right. So this was the question asked in JEE Advanced 2014. So we'll look at a way of solving this question, and as you can probably imagine, this would be a question based on relative velocity, right? So let's frame the question again and let's look at a way of solving this question. Just give me a minute. Right. So let's frame the question again, and the question again is as such. So let me draw the aircrafts A and B like point particles. So I have my aircraft A, I have my aircraft B. Aircraft A is said to be moving with a speed of 100 √3 meters per second. So the speed of aircraft A is given. And it is moving at an angle of 30 degrees with the horizontal. And aircraft B is moving with some constant speed. The speed value of aircraft B is unknown. But it's said to be making an angle of 60 degrees with the horizontal. So this is the speed of A. Let me take the speed of B to be equal to some B. Right? And now everything which is mentioned in the question is given from A's frame of reference, right? So we'll try to write down things from the observer inside the aircraft A. And in order to do that, we first need to be able to write down these velocities in the vector form. So let's start off with that. We'll first write down what's the velocity of A with respect to ground. And the velocity of A with respect to ground will be, its speed is 100 √3, its x component is 100 √3 cos 30, I cap, plus 100 √3 sin 30, j cap. So this, when we simplify, it gives us 100 √3 into √3 by 2. So that will be called 150 I cap plus 50 √3 j cap. So this will be the velocity of A with respect to ground, right? And now I know the direction in which aircraft B is moving, but I don't know what the speed of the particle is. So let me assume the speed of the particle to be equal to some V. So what will be the velocity of B with respect to ground? So writing that in terms of this unknown, the velocity of B with respect to ground will be equal to V cos 60 I cap plus V sin 60 j cap. And that will now be equal to V by 2 I cap plus V √3 by 2 j cap. Right? So this is the velocity of A with respect to ground, this is the velocity of B with respect to ground. And now since we need to solve this problem from A's frame of reference, we'll now calculate what's the velocity of B with respect to A. So what will be the velocity of B with respect to A? Velocity of B with respect to A is velocity of B with respect to ground minus velocity of A with respect to ground. So this gives us V by 2 I cap plus V √3 by 2 j cap minus 150 I cap plus 50 √3 j cap. Right? So what we're doing over here is we are simply making use of the condition given in the question. That is, we are now seeing things from A's frame of reference. So what's the velocity of B with respect to A? And we are making use of the unknown, that is the speed of B, which we assumed it to be equal to V. So we're writing things in terms of that. Anyways, on proceeding further, we get the velocity of B with respect to A to be equal to V by 2 minus 150 I cap plus V √3 by 2 minus 50 √3 j cap. So this is the velocity of B with respect to A, right? And now we'll make use of the conditions given in the question. So the first condition given in the question is, according to the observer inside A, he observes B, when he's observing the motion of B, the motion of B seems to be perpendicular to the line of motion of A. The motion of B seems to be perpendicular to the line of motion of A, right? So we'll make use of the condition. Now, so what does that mean? If I have to write that statement down in the mathematical form, the velocity of B with respect to A, that is the velocity of B as observed by an observer inside A, is perpendicular to the direction of velocity of A, right? And wherever we have a perpendicular relation, we can always make use of dot product, because we know the dot product of two perpendicular vectors has to be equal to 0. So to write this condition down in the mathematical form, I'll say that the velocity of B with respect to A dot the velocity vector of A has to be equal to 0, because the angle between them has to be equal to 90 degrees. So now let's make use of this condition now, and let's write down this dot product. So V by 2 minus 150 I cap plus V root 3 by 2 plus V root 3 by 2 minus 50 root 3 J cap. So this was the velocity vector of B with respect to A dot the velocity of A. The velocity of A was equal, you already know what the velocity of A is. The velocity of A as calculated vector form was 150 I cap plus 50 root 3 J cap. And now the dot product of these two vectors has to be equal to 0, right? So we see that there's only one unknown in this equation, and we might end up with the value of the V, with the value of V over here, which is nothing but the speed of aircraft B. So I'm performing this dot product. We get 150 into V by 2 minus 150 plus 50 root 3 into V root 3 by 2 minus 50 root 3 is equal to 0, right? On further simplifying, we get 75V minus 22,500 plus 75V again minus 7,500 to be equal to 0. So we get 150V is equal to 30,000. So from this, we get the value of V to be equal to 200 meters per second. So we got the speed of aircraft B right now, and the speed of aircraft B is nothing but 200 meters per second, right? And since we already written down what's the velocity of B with respect to ground in terms of V, and now we can write that down as well. So velocity of B with respect to ground was V by 2 I cap plus V root 3 by 2 J cap. Substituting the value of V over here, the velocity of B with respect to ground was V by 2 I cap plus V root 3 by 2 J cap. So that is equal to now 100 I cap plus 100 root 3 J cap. Right? Similarly, now we also know what's the velocity of B with respect to A in its actual form, since we found out what the value of the unknown is. And the velocity of B with respect to A in terms of this, so since now we know the value of the unknown B, we'll now get velocity of B with respect to A was, so it's V by 2 minus 150 I cap. So that will be equal to V by 2 minus 150 I cap plus V root 3 by 2 minus, I think it's 50 root 3 J cap, right? Yeah, minus 50 root 3 J cap. So once again, substituting the value of V, this was nothing but 200 by 2 is 100. So this will be minus 50 I cap plus this 100 root 3 minus 50 root 3. So this will be equal to 50 root 3 J cap. So basically the observer inside A observes B to be moving with this velocity, right? So we got this condition, we got the speed of B, and we also got what's the velocity of B with respect to A by making use of the condition given in the question, that is the velocity of B with respect to A, or the velocity of B as seen by an observer inside A is perpendicular to the line of motion of B, or in other words, it's perpendicular to your velocity vector of aircraft A. And we made use of the dot product because dot product of two perpendicular vectors has to be equal to 0. And from that, we are able to find out the value of the unknown, right? And now moving on to the other part of the question. So when A observes the motion of B, A observes the motion of B to be in what fashion, right? A observes the motion of B to be equal to minus 50 I cap plus 50 root 3 J cap. So let me roughly draw that vector. So minus 50 I cap plus 50 root 3 J cap, something like this. Minus 50 I cap plus 50 root 3 J cap. So this is the velocity of B with respect to A. So from A's frame of reference, B seems to be moving again perpendicular line of motion of A. And the speed with which B is moving right now, which you'll see will be of importance over here, would be equal to what? The speed of B with respect to A is equal to under root of 50 squared minus 50 squared, that's fine, plus 50 root 3 whole squared. So that would be equal to 100 meters per second. So from A's frame of reference, B is moving with the speed of 100 meters per second. from A's frame of reference, the speed of B is 100 meters per second, right? And the other condition mentioned in this question was at t is equal to 0, B seems to be at a distance of 500 meters away from B seems to be at a distance of 500 meters away from, right? So if, and then at a time of t is equal to t naught, it sees that B just escapes hitting A over here. So let's say that it goes really close to A over here. It goes really close to A over here after a time of t is equal to t naught, right? So the distance B has to cover from A's frame of reference would be equal to 500 meters right now if it just avoids hitting A. So the distance B has to travel from A's frame of reference is 500 meters. And the speed which B has with respect to A's frame of reference is 100 meters per second. So what time will it take for B to cover the distance from A's frame of reference? So since the velocity is constant over here, we can use the relation displacement is equal to velocity into time. So you can say that 500 meters right now will be equal to 100 into t naught. That time was t naught, the time taken for B to approach A. And now we'll get the t naught value to be equal to 5 seconds. We take the t naught value to be equal to 5 seconds. So it takes 5 seconds for aircraft B to approach really close to A over here. And as you can see, we solved we solved all of this question from A's frame of reference, right? So once again, going about this question, we had an unknown over here, and that was we didn't know what the speed of B was. So we assumed the value of V for the speed of B and then wrote down the velocity of B with respect to that unknown in terms of that unknown, right? And then we're simply making use of the conditions given in the question. The first condition given in the question was the velocity of B with respect to A was perpendicular to the velocity of A. So we made use of dot product to find out what the unknown value will be equal to. So we ended up that the speed of aircraft B is 200 meters per second. And then from A's frame of reference, B was initially at a distance of 500 meters. And then after a time of t naught, B just escapes hitting A over here. So in other words, B is traveling 500 meters distance from A's frame of reference. And from A's frame of reference, what is the speed of B? Since we already calculated what's the velocity of B with respect to A, we can now just find out the magnitude of that vector. And that is the speed of aircraft B as seen from A's frame of reference, which is 100 meters per second. So according to the observer inside A, B seems to be moving with the speed of 100 meters per second. And then after a certain time t naught, it seems to cover a distance of 500 meters. So what would the time t naught be equal to? And now it's a simple formula, that is displacement is equal to velocity to time, because the velocity is constant over here. The speed is constant over here. And from this, we get a time t naught equal to 5 seconds, right? So a simple application of the concept of relative velocity, and hopefully this was clear, right?